Early in the morning on July 20th, a lot of you woke up to the sound of heavy rain, thunder, and howling winds. A strong storm system passed across West Michigan, and it caused a lot of damage. One of the hardest hit areas was Jenison, and the National Weather Service concluded that a microburst had occurred after they got out to survey the damage. Now that microburst produced straight line winds of around 80 miles per hour. That was enough to cause extensive damage to a house, uproot very large trees. At one point, it even blew a trampoline up into some telephone wires. So this was a strong storm system, and originally it was forecast to stay just off to our north. So as late as 9 p.m. on Friday evening, the day before, this storm system was off to our west, and it was still heading straight to the east. So this is at 9 p.m. Everything was on track to pass off to the north of West Michigan and impact the northern part of the Lower Peninsula. But this is what actually happened. As you watch the radar loop, you see that in central Wisconsin, at one point, it takes just a slight jog farther down to the south. And as that happened, there was really nothing to stop it. If you'll recall on Friday, we had heat, we had humidity. In fact, at one point, our dew point temperatures were as high as 80 degrees in West Michigan. So as this storm system took just that small step down to our south, it liked the air mass that we had in place, and again, there was nothing to stop it from just tracking straight down over West Michigan and producing those very strong straight line winds. So we saw that microburst in Jenison, and this is what a microburst is. When a thunderstorm is developing, you get something called an updraft, and that updraft pushes the air up into the top part of the thunderstorm, and that keeps those water droplets suspended at the top of the storm. Now gradually, those water droplets weigh enough that they can fall back down to the surface of the earth, and so those water droplets come down, they hit the surface of the earth, and they form a downdraft. So that falling precipitation creates the downdraft, and when you're outside before that thunderstorm moves in, and you feel that strong gust of wind ahead of the storm, that's the downdraft that you're feeling. Now in some cases, you can get a really strong updraft, and that's the case in what happened with that microburst. The strong updraft suspends more water particles, more hail, at the top of this cumulonimbus cloud. So then, when that updraft weakens, which eventually it does have to do, that massive core of rain and hail, that can't be suspended anymore. There's nothing to hold it up, so it all rushes down, it plummets down to the surface of the earth. So as all of that rain falls back down, you get that really strong downdraft, and that's the microburst. In a microburst, you can get wind speeds in excess of 100 miles per hour, so it's very strong. Now, a microburst normally has a width that's pretty small, less than 4 kilometers or about 2.5 miles. So the damage itself is fairly localized, but as we saw in the case of Jenison, you can see really extensive damage in those microbursts.